All right, folks, a lot of material to cover in the section 2.2, but I'm going to try to do it relatively quickly. We're going to be talking about quadratic functions and the types of function or the types of equations you can be given with those functions. And I'm going to go through some of the brief important things about them. And then I'm going to kind of leave the application of those things up to you to try and find when you work through some of those questions and then come back and talk to me about them. So I'm going to go through some like brief examples and some general examples, but I'm going to leave the more specific stuff up to you to try and figure out. Okay. So that being said, we're going to work our way through section 2.2. And this section, there we go. This section 2.2 is going to be all about characteristics of quadratic functions. So there's really three types of ways that quadratic functions can be listed, and there's important pieces of information that things can be brought up from those things, okay? So there's really, you need to have 3 points for a quadratic function to be able to graph, like a parabola to be graphed. Each equation lends itself very nicely to find 2 pieces of information, and it makes it kind of a pain to find the third. So every once in a while, you're going to have really, really good questions that relate really well to one type of function, and then we're just going to change, a few things to make it easier to deal with. All 3 of those types of functions, it's very important that we understand the axis of symmetry. So you all know what a line of symmetry is from geometry. A line of symmetry is the line that mirrors, oops, that's supposed to be an R, a line that mirrors the parabola. Now, an important thing that you need to know is that the axis of symmetry goes through the vertex. So the axis of symmetry goes through the vertex, okay? This brings us to our very first type of equation. The very first type of equation that we're going to deal with is the vertex formula. Now, yesterday we had talked about the importance of the A, the B, the H, and the K. In vertex formula, and actually this entire section, we don't deal with the B value. Remember how I said I wasn't a big fan of that? So it's y equals a times x minus h squared plus k. So it's really nice. This one lends itself very, very nicely to us because what we need to do is we need to find the vertex. The vertex is actually given to us in this formula. So if we think of the parent function is shifted or is at 0, 0, and then h will shift us left or right, and then k will shift us up or down. So if I have to shift left and up or right and down or whatever it is, that's where the new vertex is going to be. So the vertex is going to be given by h comma k. And we just said that the axis of symmetry goes through the point h, or through the vertex, which means it's going to go through the point h, which means that our axis of symmetry is the line x equals h. Okay? Now that's the importance of vertex formula. Now one thing that the book really wants you to understand is with the axis of symmetry, if I have a picture or if I have a graph, and if I know where my vertex is, like let's say it's there randomly, and I know that there is an axis of symmetry that goes through that vertex like this, I know for a fact I need 3 points to define my parabola, right? Because the vertex, or since this is the vertex, it's either going to go up with a mirror image or it's going to go down with a mirror image. So the thing that your book wants you to understand is if I can find just one other point, doesn't matter what that point is, if I can find just one other point, like let's say it's here, I can reflect that over the axis of symmetry, and I now have found my 3rd point, and I can now graph my parabola. So that's what your book wants you to understand of the importance of the axis of symmetry. So that's what you have to be able to do, okay? So for instance, if I look at an example, just a very quick and easy example, if I want to graph, and I want to do this, whoa. I'm going to get rid of that one. Is it gone? Okay, apparently it's gone. Sorry, I thought I had this sorted out earlier, but apparently it changed. All right, so if I have just a normal graph or a normal equation, and what I want to find from that normal equation is something that looks like this. If it says like y equals 2 times x minus 3 squared plus 2, I should be able to find my vertex almost instantly. My vertex is given to me by the point h comma k, which means it's going to be 3, 2. So I can plot the point 3, 2, and my vertex is done. It's also really easy because it tells me that my axis of symmetry is going to be this value, which is 3. So I can draw my axis of symmetry going right through here. Now, like I said originally, it's really, really important that you understand the axis of symmetry, because now I just need one other point and I can graph this thing. So what you should really be focusing on is you should be focusing on your ability to plug in points to save yourself time. So right now, I'm just going to pick a point that's 1 away from my vertex, because that's probably going to be the easiest one for me to solve. But you can plug in any point that you want and it'll help you graph it. So if I look at this, let's say I want to plug in x equals 1. When I plug in x equals 1, I get 2 times 1 minus 3 squared plus 2. 1 minus 3 is negative 2, so I'm going to have 2 times negative 2 squared plus 2. Negative 2 squared is 4. 2 times 4 is 8. 8 plus 2 is 10. Making sure I did that right. Negative 2 squared is 4 times 2 is 8, so 10. So I'm going to have the point 1 comma 10. So I go over 1 and I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have this point here. Now I know that this is going to be mirror imaged directly over the axis of symmetry, so I'm just going to count 1, 2, and then I'm going to count over 1, 2, and I know that this is the next point on the axis of symmetry. So I can then connect these points here and here, and I'm all done. Okay? Now that's a really, really important concept, because as long as you understand that, you're good to go. Now, one thing I want to mention to you is the idea of a maximum and a minimum value. Okay? The vertex can either be the maximum or the minimum of a function. And in this case, specifically, this is a minimum value. This vertex is a minimum. So one thing I want to mention to you is if the vertex, or if the function opens up, and that means that the a value is positive. So if the a value is positive, which means it's not negative, that means the parabola is going to end up looking something like this, and the value will be here, the vertex will be there, which will make this a minimum value. Okay? And the other thing that the book wants you to do is be able to understand where these are increasing and decreasing. Read this like you're going left to right on a book. So as the function goes from the left to the right and I'm approaching the vertex, my arrow is going down. This is called decreasing. And then here, if I continue from the vertex to my other side of the function, I'm going up, so this is increasing. Okay? Now let's say the function opens down. So if the function opens down, that means my a value is less than 0, which means that it is negative. That means that my function is going to look something like this, which means that the parabola has a vertex that is a maximum value. And then now, as I look at the increasing and decreasing, if I start from the left and I go towards the vertex, that means this is going to be increasing, and this part is going to be decreasing, because notice how the direction of the arrow is going down. Okay? Now that's something that as you kind of work your way through, your book might ask you questions and say something like, describe what's happening to the function as it approaches the vertex. So it's going to be increasing from the left and decreasing to the right. Okay? So that's just something to kind of think about. Okay? Now there are two more types of varieties or formulas or whatever you want to call it that these parabolas can be in. But in this case, the next one is the standard form. And standard form is probably what you're the most comfortable looking at. And that is in the form y equals ax squared plus bx plus c. Standard form looks like this. Now, remember I said some of them lend themselves really nicely to a couple pieces of information and kind of challenging towards the other ones. This one's kind of tough because it forces you to find the vertex. The formula to find the vertex looks like this. So you have your b value and you have your a value. You're going to plug in your b into this formula and plug in the a into that formula. Okay? So that's kind of the tricky part. And actually, I'm sorry, that's not the vertex, that's the axis. So the axis of symmetry is given by negative b over 2a. Now remember, the axis of symmetry has the vertex on it. So what we know is that the x-coordinate of the vertex, if I look at the vertex, the x-coordinate of the vertex is going to be whatever that is. Okay? The y-coordinate, where it's placed on the axis, is what happens when you plug this in to this. That's what that's going to look like. Now, I know that looks really trivial, but we are going to plug this thing in to here for x, and that will give us the y value. Okay? So then the very last thing, the easy point, remember I told you there was an easy point? It always gives us the y-intercept of the equation. The y-intercept of the equation is just c. So whatever the c value is, it's 0, c. So it tells you what that is. So I'm going to go through and find the important points with you, but we won't go through the graphing just to try to save some time. So let's say I have the equation y equals 2x squared plus 3x plus 7. If I want to find the axis of symmetry, I'm going to do negative b, which is negative 3 over, and actually let me change this a little bit. I just made this up on the fly. Let's change it to 4. So it's going to be negative b over 2 times a, which is the same thing as negative 4 over 4, which is negative 1. So it tells me that my axis of symmetry is going to be at negative 1. Okay? Now, if I want to find the vertex, I'm going to take that point that I just found, negative 1, comma, and I'm going to plug this thing in to here. So it's going to be 2 times negative 1 squared plus 4 times negative 1 plus 7. So negative 1 squared is positive 1, 2 times 1 is 2, minus 4 plus 7, 2 minus 4 is negative 2, plus 7 is 5. So that tells me that my vertex is going to be at the point negative 1, 5. Now finally, the last part, this tells us where our y-intercept is going to be. So I know that my y-intercept is going to be the point 0, 7. So here's my points. If I were to put this on a graph, I know that my vertex is at negative 1, 5, somewhere up here. I know that I have a new point, which is going to be the y-intercept, which is at 0, 7. And then if this is my axis of symmetry, I'm just going to reflect it over that to here, and I've got my graph. Okay? Should be pretty straightforward, should be pretty simple once you understand the underlying concepts of it. Okay? And then the last thing, I'm trying to go kind of quick so that way we can make sure that we get everything covered. The last one is intercept form. Sorry, my handwriting is like a third grader's, but I can't write any better on this thing. I've tried. So the last one is intercept form. This is y equals a times x minus p times x minus q. Okay? So this is the only other form that we could actually have. That other form doesn't tell us as much. The other forms don't tell us as much. This tells us almost everything we need. Okay? We just have to find the vertex. So this gives us two really nice pieces of information. It tells us that the x-intercepts are 0, I'm sorry, nope, I don't want to do that. It tells us that the x-intercepts, where it crosses the x-axis, are p, 0, and q, 0. So it tells us that this is going to cross the x-axis in two locations, and it's going to cross at p and q. Notice they're the opposite. So again, if this said something like y equals 2 times x plus 1 and x minus 2, my x-intercepts would be -1 and +2. Just like they always have been, they're opposite x's, okay? Now, the thing that makes it kind of tricky is now we have to find the axis of symmetry. If we're looking at the axis of symmetry, this is going to be p plus q over 2, okay? Again, so here, if we're finding the axis of symmetry is -1 plus 2 over 2, which is going to be -1.0, positive 1.5, or 0.5. or 1/2. -1 plus 2 is 1, over 2 is 1/2. Okay, so now the last thing with the vertex, it's very similar to what we just did. We take P plus Q over 2, and that gives us our X value. And then we are again going to plug this into that. So in this one, if I want to find the vertex, my vertex is going to be 1/2, comma, and then I'm going to plug 1/2 in right here. So I'm going to have 2 times 1/2 plus 1 times 1/2 minus 2. So it's going to be 2 times 1.5 times -1.5, I think. Yep. So that's going to be 3 times -1.5, which is going to be -4.5. So then I'm going to get -4.5. So that's what that looks like. Okay. I know I kind of went through things relatively quickly, and I know I went through things a little bit rushed, but I wanted to make sure I got all of this information to you in a form that wasn't super long. So I got the basics of the information to you, but now it's your job to try and figure out where the confusing points lie. You need to figure out what part of this doesn't make any sense. So that way, next time you come back, we can have a real conversation about it. So that way we can go through and fine tune anything we need to fine tune. Okay. I think for the most part, you guys will be able to figure your way out through this thing. So you can kind of look at the general forms that I just made and now apply those general forms to the problems that are in the book. So if you have questions, don't hesitate to let me know. You can save them for the next class. Remember, we're going to have a homework quiz. So make sure that when you come back, we can talk about it and we can figure these things out and kind of get your issues ironed out. Okay. Have a good day and thanks for watching.